When you go online to buy a pair of sneakers today, you can often design them exactly the way you want. You pick the neon laces, you choose the custom stitching, and a few days later, your unique shoes arrive at your door. For most of industrial history, this level of customization was impossible. Traditional factories were built to do one thing: produce millions of identical items on a rigid, unchanging assembly line. Today, that old model doesn't work. A modern factory has to build your single, highly customized shoe right alongside thousands of other completely different orders on the exact same line. This requires a new kind of flexibility. Physical robotic arms and conveyor belts cannot provide that flexibility on their own. To keep production moving without a human having to step in, those machines rely on an invisible layer of intelligent software working behind the scenes. Modern factories rely on two specific types of software to manage this chaos: the digital twin and the software agent. Think of the digital twin as a flawless set of virtual eyes and ears, and the software agent as an active, decision-making brain. This partnership is what drives Industry 4.0, a production floor that can adapt to changing orders and solve its own problems on the fly. A digital twin is a virtual replica of a physical machine, updating in real time. Its core strength is its accuracy, continuously monitoring physical details, like how fast a motor spins, the stress a joint is under, or how hot the equipment gets. If a robotic arm assembling your sneaker starts running 5 degrees too hot, the digital twin sees that change immediately. But the digital twin has a limit. It is strictly an information gatherer. It can see the problem perfectly, but it cannot reach out and change the machine's behavior to fix it. Having a perfect virtual mirror is only useful if you have a way to take action based on what that mirror is showing you. That brings us to the software agent. This is the smart manager, the active brain attached to the equipment. The agent has autonomy. This means it has the authority to make independent decisions on the fly, without waiting for a human operator to push a button. It also has sociability. Software agents are constantly talking and negotiating with other agents across the entire factory floor. So if an agent realizes its machine needs to cool down, it can instantly negotiate with a neighboring healthy robot to take over your custom sneaker order. The agents provide the action and the teamwork, but they are essentially blind without the digital twin's data to guide their choices. This chart shows exactly how these two systems divide the labor. Notice the left side, where the pale pink bars show agents dominating in tasks like decision-making, coordination, and negotiation. The data proves that agents are primarily used for the collaborative planning and physical execution of the production process. Now look at the right side of the chart. The dark blue bars show where digital twins excel, things like simulation and condition monitoring. This confirms that twins are strictly applied to monitor resources and process the massive flow of information. The divide is clear. Digital twins own the information, while software agents own the execution. They fit together like two halves of a complete system. Let's see how this works for your custom sneaker order as it moves down the line. Suddenly, the robot tasked with stitching your shoe starts to overheat. A chain reaction happens in milliseconds. The digital twin flags the temperature spike, and the software agent instantly reroutes your physical shoe to an alternate robot before a breakdown ever occurs. By combining high-accuracy monitoring with independent decision-making, the factory can practically heal itself and keep production moving in real time. This balance between information and action is the foundation of a decentralized, intelligent factory. This partnership allows a factory to juggle thousands of unique, individualized orders while staying as fast and efficient as an old-school assembly line. So, the next time you order a custom product, know that you are initiating a massive, invisible conversation between virtual mirrors and digital brains, all working together to bring your unique idea into reality.